The sign of a quadratic. Well, what they're talking about a sign is whether it's positive or whether it's negative. So the first term we have is positive definite. What does it mean? It means it doesn't matter what value we substitute in for x. We know the answer is definitely going to be a positive number. So it must be a parabola which is always above the x-axis. So given that information, we can come up with some conditions. One of the conditions would be that it's concave up, so a would have to be greater than 0. But the other condition would be, well, there's no x-intercepts or no solutions to the equation, so the discriminant would be less than 0. So it's one way, I guess, of proving a function is always greater than 0. We don't actually have to go and solve it or do anything like that. We can go look at it and say, oh, hang on, it satisfies the conditions for positive definite, so therefore this must always be greater than 0. There, of course, is a matching one, negative definite, where it's always below the x-axis. So this one would be concave down. Discriminant's still less than 0, because, of course, there's still no x-intercepts. So that would be the condition for proving it's always negative. So it doesn't matter what value of x we put in, we're definitely going to get a negative value. Then we get these boring ones, indefinite. In other words, we don't know when we put x in whether it's going to be positive or negative. There's that sort of one where it just touches the x-axis. So I suppose that one would be concave up, discriminant equals 0. We could have an upside down one that touches the x-axis. Again, it would be concave down in this case, but discriminant 0. We could have one that cuts it completely. That one would be concave up, discriminant greater than 0, and an upside down one. As I say, indefinite ones are pretty boring. We tend to ask about positive definite, negative definite. I mean, that gets more useful information. But if they do use the term indefinite, I suppose if we summarise that, it doesn't matter what the concavity is. The key would be discriminant greater than or equal to 0. That would get us indefinite. As I say, more likely they're going to ask us something about positive or negative definite. So what values of k would that make this function positive definite? A is greater than 0, so first thing I know is k's got to be a positive number. The discriminant has to be less than 0, so b squared minus 4ac. K squared is greater than 9, which means k is either less than negative 3 or greater than 3. But of course, both conditions have to be true. So I'm looking for something that's both greater than 0 and satisfies the second condition. In other words, it's only going to be greater than 3 that I could use. So k is greater than 3. 8g. Ooh, 17 with an asterisk. That must be one of the extension questions.